What do I do next? No, it's quadratic. So I will definitely multiply both sides by -1 and multiply actually by -10 because I don't want any decimals in there. It's easier for me. It doesn't have to be for you. So I multiply both sides by -1 and also by 10. It's easier for me to punch in numbers. So then I go back to my calculator and okay, so I have let me write it. It's easier if I write it first. So that's x equals -b. So that's 24 plus or minus. Of course, I'm applying the quadratic formula. Sorry about that. So -b plus or minus b squared minus 4ac. 4 times 8 times 60 divided by 16. -b, 24, plus or minus the square root of 24 squared, minus 4ac, but since c is negative, I change this into positive. 4 times 8 times 60 over 2 times 8. Okay, ready? Left parenthesis. I think we've done this before, but let's do it one more time. I have 24 plus the square root. Where are you, square root? I see it. Parentheses 24 squared and plus 32. I multiplied for simplicity, so I don't have to punch in so many numbers. And get outside, close the parenthesis, and I divide by 16. And then I just copy all this, and I go back and I change or override the plus into minus, and it's going to give me those solutions. Okay, 4.6, so x 4.6 feet, and x equals -1.6 feet. Any questions on this? Okay. So so here's the situation. If we want to graph it, we don't have to, but this is 6 feet, -1.6 somewhere here, and 1, 2, 3, 4, 5, 6. So here is above 1.5. Right here is the maximum height, and here is that 4.5 feet between this point and this point. 4.6. I'm sorry, 4.6 feet. Part C, graph the function. Okay, fine. So I would have graphed the axis of symmetry, of course, which is 1.5. And my graph does not look symmetric at all. So 1, 2, 3, 4. Yeah, here's y. Now I got it. I realized that something was not right. Has to be symmetric with respect to, even now that is perfect, but before it was just, I didn't count my units correctly. Okay, good. So now it looks better. It's not perfect, but at least it looks symmetric. Okay. Now again, this was a complete review from your previous course from intermediate algebra. What I would like to talk about now are those polynomial functions. And you can say, but what was this? Yes, this was a polynomial function. What was it? Its degree? Very good. So we know degree 1, which is linear. We know degree 2, which is quadratic. But now we want to look at polynomial functions of a higher degree. Cubic, 4th degree, and so on and so forth. Here are those two categories. Odd degree So they're all polynomials. Even degree. This has nothing to do with odd and even functions, which, by the way, I was surprised on the test. Very few of you, when I asked the question, show whether it's symmetric or not, very few of you determined this. And realize that there are three possibilities, either equal to f of x, or equal to negative f of x, or none of the above. This is what we did in class. Okay, I was surprised not to see this. Okay, so this has nothing to do with this. This would have been even, this would have been odd. So odd degree or even degree has nothing to do with this. We are using the same word, like odd and, or words odd and even, but they mean totally different things. Here, I'm talking about a function like this, of an odd degree, which is 3. Here I'm talking about a function like this, which is degree 4. They may or may not be symmetric functions, but that, as I said, has nothing to do with an odd function or an even function. Okay. Now, when we graph an odd degree, like cubic function or 5th degree or 7th degree, I'm not going to go that far. There is no need. Once, if we understand degree 3 and degree 5, you will be able to graph any odd degree polynomial. And if you understand how to graph the square quadratic function and x to the 4th, you will be able to graph any even degree with no calculator whatsoever. You will check with a calculator, but it's not going to be difficult at all. Okay. Now, remember when we graphed the quadratic function, I had to go through a lot of steps, right? I had to go through shape, vertex, x-intercepts if they exist, y-intercept, axis of symmetry, and maximum value or minimum value, depending on the function. When we graph cubic or 4th degree or any odd or even degree, we have a little bit more work to do than just those steps. Some of those steps don't apply here, but we do have a little bit more work. I'm going to choose a problem from your book, or I let you choose. I'll tell you where they are, and you choose. I would like you to choose an odd degree first. Oh, it doesn't matter. You can choose odd or even. You just tell me what you're choosing. On page 361, I would like you to choose anything you want from 41 through 64. But I want you to tell me, I'm choosing this, and the degree is that. And that's what we start with. Say it again. I'm sorry. Forgive. We want to start with 41. Okay. So here's 41. F of x equals x to the 3rd plus 2x squared minus x and minus 2. Can anyone identify the degree of problem 41? Yes. Yes. Okay. First thing that I'm going to ask you to determine is, I don't need the book, let me put it aside, is the what? Excellent. Although you can say, but you didn't ask me to find the domain for the quadratic functions. True, I didn't, because it was the very first step after linear functions, so we know it's all real numbers. Okay, degree 3, perfect. Domain? Of course, all polynomial functions are friendly functions. Good. So I'm going to make a list on the side of things that need to be determined. So list. Well, number 1, domain. You already told me. Number 2, x-intercepts. How do I find the x-intercepts of this function? Right, for any function. Okay? So I have x to the third plus 2x squared minus x minus 2 equals 0. 4 terms. What do I always try with 4 terms? Is not guaranteed that it's going to work, but my only chance with 4 terms is very good. So please group and tell me what you get. Yes, in parentheses. What do I have to have in parentheses coming out of the other two? Otherwise, I can't continue. The common factor goes out, which is? Very good. And then I'm left with?
X squared minus 1.
How do I factor x squared minus 1? Since the degree is 3, how many solutions will you come up with? Right. Even if they're imaginary, I will not be able to plot them. They will not cross the x-axis, but I have to have 3 solutions. In this case, they all exist. X equals, x equals, x equals.
-2, -1.
Excellent. I go back to my chart. I will put them in ascending order as I see them here. -2, -1. 0 must be in the chart, and then 1. Please tell me what to write under -2, -1, and 1. You don't know what to write under 0 just yet, but you will know what to tell me to write under -2, -1, and 1. Do I write 5? Do I write 3? 2? How do I get these 3 numbers? How did I get these 3?
So -2 to the third plus 2 to that.
0. That's how I started.
Oh.
Right?
Yes.
Good. Excellent. That's how I got those, right? When y is 0. Perfect. Okay. So I found the domain. I found the x-intercept. Number 3, y-intercept. How do I get the y-intercept? X equals 0. So please plug in 0. And here's the function. What do you get? Zero, 0, 0, -2. So then 0, -2. I go back to my chart. What do I write under 0? -2 indeed. Okay. Step number 4. Max, min. This part I cannot do without a calculator, but I know it has to be on the list. Step number 5. I ran out of room. Step number 5. Symmetry. How do I check the symmetry? And that's why I reminded you how to find the symmetry. In all cases, I have to find f of -x. So what about f of -x? So the function is -x to the third plus 2 -x squared minus -x and minus 2. Now, before we calculate this, do you think that the function that crosses the x-axis at -2, -1, and 1, can it be symmetric with respect to the y-axis or symmetric with respect to the origin? If it crosses at -2 and -1 and 1, could it be symmetric with respect to the y-axis? No. If it crosses at -2 and -1 and it does not cross at 1 and 2, it cannot be symmetric with respect to the y-axis. Right? That's for sure. You agree? So if the function crosses at -2 and -1 and it does not cross at 1 and 2, it cannot be symmetric with respect to the y-axis. Agreed?
Yes.
Okay. So now also if it crosses at -1, -2, whatever happens on this side, which I may or may not know, has to be symmetric on, so from the second quadrant to the fourth quadrant, right? Or from the first to the third to be odd, symmetric with respect to the y-axis. That's not going to happen, but let's calculate. So -x to the third is -x to the third. But -x squared is x squared times 2, so this does not change, and this change, and this doesn't. So here's the original function. So 1, 2, 3 signs change, but not the last one. So obviously the function cannot be symmetric in any way, right? Because these two are not the same, so I already know it's not even. And all these signs have to change for the function to be odd. So now I know it's not symmetric. Not symmetric. Okay, step number 6 on the list. Something that we have not talked about before. End behavior. What is the concept of end behavior? So a quadratic function can open upward and have a minimum, right? The end behavior means where the function is going. Where is this function going? To positive infinity. So if it has a maximum quadratic function, where will it be going? What will be the end behavior? Negative infinity to negative infinity. Well, this is a degree 3. So this function, because it's degree 3, does not look like this. And it cannot look like this, because that would be an even function, an even degree function, right? It must look like this, like the linear function. It must have the same type of behavior with a linear function, because it's the same, it's odd degree. It's coming from negative and going to positive. Well, what is the other option? Exactly. So what is the leading coefficient here? 1. 1 is the leading coefficient, right? So what do you think it will look like? I don't know what happens in the middle, but what about the end behavior? Will it be like this, or will it be like this? Number 1 or number 2?
Positive and negative.
If the linear function has a positive slope, does it look like this, or does it look like this? Right. So will the cubic function. So will the 5th degree function. So will the 7th degree function. Any odd function behaves like end behavior like the linear function with the same slope, same leading coefficient. So since this function has a positive leading coefficient, it will come from negative infinity and go to. So when x approaches negative infinity, the function will approach. One more time. When x approaches negative infinity, where does the function go?
Negative.
Right. When x approaches positive infinity, where does the function go? Right? So what will I write under negative infinity for the function value? Correct. And what will I write under positive infinity for the... Right. What if, don't change anything, what if I had here negative? How will that change these two? Exactly. When x approaches negative infinity, the function will come from positive infinity. When x approaches positive infinity, the function will go towards negative infinity. And this happens for any odd degree function. If it's linear or cubic or 5th, all behave the same. So this is the end behavior. And I have one more item to discuss, and then we can graph the function. Okay, last item, which is number 7. It's what it's called multiplicities. Multiplicities. Okay, what is that? What is that? Correct. How many times? Yes. Okay. So let's suppose I have x cubed equals 0. So it's a function which is x cubed, and I want to find its x-intercepts. How many solutions will you give me? Yes, and it happens that all of them are. This is what we call multiplicity of 0. It's 0. How many times does 0 appear as a solution of this?
1, 3.
3 times. So so x equals 0 has 3, or multiplicity, I should write better. Multiplicity 3. Okay, what about this function? This function set equal to 0. X minus 1 squared equals 0. How many solutions will this equation have? 2. X equals, and x equals 1. So what is the multiplicity of x equals 1? Yes, x equals 1 has multiplicity 2. Okay, what about the equation x plus 2 equals 0? How many solutions does this one have? Yes. So what is the multiplicity of the solution negative 2?
1.
1. So x equals negative 2, multiplicity 1. Okay, and you can say, okay, I know how to add or find the number of times the solution appears. But what does this have to do with our discussion on polynomials? A lot. So here's how I will graph a multiplicity 1 at negative 2. Here's negative 2, multiplicity 1. This is one option, from below to above, or the other option from above to below. Here's how I will graph a multiplicity of x equals 1, which is 2. And I know how to graph it because I studied it in chapter 2. How do I graph the multiplicity at 1 in this case? A turn, right? It's either this, if it has a positive leading coefficient, or like this. Okay, for x equals 0, how will I graph that multiplicity? Right. And we know that because we graphed this when we talked about odd functions. So here's the multiplicity 3. Okay. So every odd multiplicity, 1, 3, 5, what will the function do? Will it cross the x-axis or will turn on the x-axis? Yes. All odd multiplicities, if the solution appears once, is a normal cross. If a solution appears 3 times, it's a smooth cross, something like this. Not fast, go slowly. This is multiplicity 3. This is multiplicity 1. What about this? 2. What about this? It's only one solution in there. Exactly, 4. Because it goes very smoothly. So multiplicity 4 here, multiplicity 2 here, multiplicity 1 here, multiplicity 3 here. What about this one? 5. So coming back to our graph, the solution negative 2 has multiplicity 1. Solution x equals negative 1 has multiplicity 1. Solution x equals 1 has multiplicity. So all of these, I'm making myself a note, are a regular cross. Regular cross. Nothing special happens there. I shouldn't put it here because that's always regular cross. I meant 1. Regular cross. I'm ready to graph this function. We talked about multiplicities, we talked about end behavior, we talked about domain, we talked about x and y intercepts, max, min, I can't. I think this is 10. Okay, ready? Oops, right. Okay, here it is. Negative 2, 0. Negative 2, 0 is the first point I plot. Negative 1, 0. Second point I plot. 0, negative 2. 1, comma 0. I need the chart in front of me when I do this. Now, please remember polynomial functions are smooth continuous functions, something like this. Or like this. Okay? Nothing is forced. So if I have to do this and then come whatever, something is not right. So I see that this function is coming from negative infinity. I'm going to graph it in pencil if I find it quickly. Okay? And then we'll come back and adjust the graph. Okay. So I know it's coming from negative infinity and it has to cross. It is a regular cross, multiplicity 1. I know it has to come back. It has to have a maximum somewhere here because it has to come back and cross again. I don't know if it turns here or it turns here. That part I don't know. But I know that it has to come back and cross the y-axis. But I think that this is forced. I don't know. Maybe this. This appears to be forced. So I'm hoping that something like this. I don't know. You just pick the function. I didn't look at it. So I'm hoping or assuming more than this is the case. It can turn here. Unlikely. It can turn before. A little unlikely because this is kind of forced. Of course, my unit is not perfect. Or here. But there is nothing else that can happen. It must have a turn. It must have another turn and has to go up, according to this. So it crosses a negative 2, 0. It crosses again a negative 1, 0. It crosses the y-axis. I'll see in a minute with a calculator. And it goes up. Now, maximum possible number of turns for all polynomial functions is degree minus 1. It doesn't have to turn twice, n minus 1, right? In this case, it has to. So this is 3 minus 1, so it has to have maximum 2. For example, x cubed. We talked about x cubed a minute ago. When I graph x cubed, what is the maximal possible number of turns for x cubed? It doesn't have any. So it doesn't have to have, but it cannot have more than 2 turns. Okay, so here is my take on this graph, and I'll come back and make adjustments. So here it is. This appears smoothly to me, and it has to have a turn here and a turn here. So this will be a local or relative max, and this will be a local or relative, and I have to determine them. So let's put this function in the graphing calculator. Let me clear whatever I had before. Okay. So we had x cubed. I think it was plus 2x squared.
Yes.
Thank you.
Minus
2
x.
minus x and minus 2.
Yes.
Okay. I will choose the standard viewing window. So it must cross at negative 2, it must cross at negative 1, it must cross at 0, negative 2, it must cross at 1, comma 0, and that's the graph. Now, in order to determine this maximum between x equals negative 2 and x equals negative 1, I go to second and calc. I select maximum 4. I will give the calculator -2 to look for the maximum as the leftmost point, and -1 as the rightmost point. Really? What did I do? Be nice. Okay, 4 again. So -2 and -1. And I don't want to guess. I don't care. Just give me the maximum, please. So it's giving us the maximum is at -1.5485, and the maximum is 0.63. These I could have never determined with the graph without the calculator. So I go back to my chart where I have the chart and insert that point in there. -1.5, comma 0.63. I'm going to repeat for the minimum. I see that the local minimum is passed to the right-hand side of the y-axis. So somewhere between x equals 0 and x equals 1. So second and maximum, I'm sorry, minimum I meant to say, 3. I want between 0 and 1. No, I'm not going to guess, just give me the value. And as you see, it's giving us 0.21, -2.1. I will put it in my chart, 0.21, -2.11. So these are the extra points that I just put in. And now I can put them here also. This one was -1.5, comma 0.63. And this one, the local minimum was 0.21, comma -2.11. Now, no one can come up with anything extra about this function. This is it. I would like you to choose from the same page any even degree function.
47.
47. 47. Yes, it is. Very good. So I have 4. I have 8. I have 9. And I have 10. Any questions for me? Okay, 47. And we have f of x equals x to the 4th minus 2x cubed plus x squared. Yes, the first function we graphed, it took us, I don't know, 20 minutes. Now they will take us less and less and less till we get to about 2 minutes maximum. Okay, domain. Degree. Good. What is the maximum possible number of turns? Yes. Max possible 3 turns. Okay. Let's start with the end behavior. As you notice, I put everything in my chart and I use the chart to graph the function. Since this is similar to x squared, it can look like this with something else in the middle. It can look like this, or it can look like this. Which one is it? And yes, how do I know? Because x squared with a positive leading coefficient will do this. So will x to the 4th with a positive leading coefficient. So what is the end behavior without even thinking? Okay, let me look silly again. Exactly. Similar to x squared. No questions asked. Good. Now, I need the x-intercepts. How do I find the x-intercepts? Y equal to 0. X to the 4th minus 2x to the 3rd plus x squared equals 0. What will you tell me to do first? Very good. And then? Good. And we have a contract on this. How many solutions will you give me? Good. X equals, X equals, X equals, yes, and X equals. What is the multiplicity of 0 and what is the multiplicity of 1? So multiplicity 2, when I put them in the chart, 0 and 1, 0, 0. What do I write up here? Do I write a cross? Do I write a turn? Do I write a cross flat? Do I write a turn flat? What do I write? For multiplicity 2, 4 is a turn flat. 2 is just a turn. Just a turn. Good. So then I know that this must be a turn, and this must be a turn. There is no discussion about the y-intercept because when x is 0, y is 0. So let's go through the list to make sure that we checked everything. Domain, yes. X-intercept, yes. Y-intercept is one of them. Max, min, I can't without the calculator. Symmetry. So this will not change, this will not change, but this will. Will this function be symmetric? That has a turn at 0 and a turn at 1? No. So I will like not symmetric. At least write something. So I know you didn't forget. End behavior, done. Multiplicities, done. I'm done. I just have to graph it. So let's graph it. So I have to plot 0, 0. I have to plot 1, 0. So now let's look at the chart and come up with an idea. Okay? The function comes from positive infinity and it turns at 0, 0. Okay, again, I'm using my pencil for a second. It's coming from positive infinity, has to turn at 0, 0. Must do something here because it has to come back to 1, 0 and turn again. So it has to go to a maximum because it has to come back and turn again and go to infinity. So I think that this is the graph. A little forced. I think that this maximum is a little bit smaller, so the graph is a little bit smoother. I think this is not too high, but we don't know without calculus. I do this with my students right now, tonight, but no calculator. But we can in college algebra. So this is my f of x, which is x to the 4th minus 2x cubed plus x squared. I put all this information in the graphing calculator. I clear what I had before. And that's x to the 4th. And then minus 2x to the 3rd. And then plus x squared. I use the same viewing window. I'll say the standard. And it's coming from positive infinity. It has to turn at 0. This is impossible, and it has to turn at 1. So I have to change the viewing window, and I'm going to say between -2 and 3, and between -1 and 6. So I can see what's happening there. I may or may not. Okay. Let me go back. I want to change this. I don't know why it doesn't show. Oh, I see why it doesn't show. Okay, so -2, okay, and then, of course, y minimum is -1 to 6. Okay, I got it now. So it's coming from positive infinity. It turns at 0. It's a very small maximum here, as I expected. So again, this is not good enough. So I'll go back and change that 6 into 1. Okay, it's coming from positive infinity. It turns at 1. Aha, it goes to a tiny, tiny maximum, comes back at 1, it turns and goes up. So now I know that there is a maximum between 0 and 1. So second and calc, I want a maximum which is 4. I want the maximum. Please find the maximum between 0 and 1. No, I'm not going to guess. Just give it to me. So the maximum is roughly in the middle. It happened. It doesn't have to. Is at 0.5 roughly. And the maximum is 0.06. It's a tiny maximum. If we hadn't had this discussion before, I'm pretty sure that some of you would have copied something like this. Would you agree? Right? Yes, please. Priya?
For the maximum, would it be the maximum value or the y equals value?
The maximum value is always y. It's the height.
So we wouldn't put the 0.5. Will we just put 0.6?
So in the chart, I have to write x equals 0.5 and the height is 0.06.
But the answer would be 0.06.
Yes, where the maximum is obtained when x is 0.5. The maximum is 0.06. So of course, this is way too high. So if I want to go back and adjust my graph, I would do something like this. As expected, as I said, if you have to force it on paper, you know something is not 100%. Thank you for coming. What we are trying to do is I'm trying to finish chapter